Okay, let's wait 1 more minute. And then I think we can start. Okay, so I think we can go ahead and start. I will start by introducing myself. My name is Marina and I work for F6S as a communication manager. I am one of the people that deals with the communication part of AI Plan for You. And I also support my colleague Luisa, which is also here and will speak to you later on this session. Okay, so let's start by going through with the agenda. First of all, we will have Andrea, our coordinator, talking a bit about what is AI planning and what is the AI Plan for You project. He will explain the concept of these topics. Then we will pass the word to Guglielmo from Magazino that will talk about the Magazino use case and how it fits in the project. The same for Lorenzo and Marco. They will also present the use case brought here by Saipem. Then we will hear from Luisa, our open call coordinator, my colleague. She will walk you through the procedures and how to apply and what you need to do to apply well to this opportunity. And then we will have some time for some questions. I would also like to say that during all the session, if you want to post the questions on the chat, we will be answering, so feel free to use the Q&A or the chat itself. We will answer all your questions, hopefully, and clarify all your doubts. So I think I can stop sharing now and give the word to Andrea.
Thanks a lot, Marina, and hi, everyone. Let me share the screen. Here I am. I hope you can see the screen.
We can.
Let me move your face here, Marina, so that, okay. Hello, everyone. So I'm Andrea Micheli. I am from Fondazione Bruno Kessler, a research center in Italy. And I am the coordinator of this European project called the AI Plan for You. And today I'm going to introduce you a little bit what is the project about. And as Marina pointed out this question, what is AI planning after all? Okay, so I will try to give you this bit of information. So let me say a few words about the project itself first. So it's a European initiative. We are several partners, and as you can see, we have some research centers. We are 7 research centers scattered throughout Europe, and companies and small medium enterprises also from different European countries. And we joined forces together in order to try to bring automated planning to a more relevant position to make impact to the European market. Okay, so the idea will be to take this technology that I will talk to you about and apply it in different use cases and show the potential and the applicability of this technology in actual production environments. And demonstrate it by means of all these use cases. And the open call that is currently open in the project is actually looking for exactly this one: new areas, new domains in which this technology, automated planning, can actually make an impact. I will also give you a little bit of introduction on the AI, let's say, landscape in Europe and as it is sustained by the European Commission. And one very important initiative that the European Commission financed and is currently up and running is this AI for Europe platform, or as it is officially called, the European Platform for AI on Demand. The idea here is to create a place, actually a digital space in a way, that brings together the AI stakeholders, so both people that are looking for AI solutions and people that are actually providing AI resources such as data sets or AI technologies like planning or machine learning and these kind of things. So the idea of AI for you is really to try to bring these people together in order to accelerate innovation and lower the entry barrier for small medium enterprises or for low tech sectors in order to reap the benefits of artificial intelligence. And planning, as we shall see in a moment, is one of the founding areas of artificial intelligence. That's why in our project, we strongly believe that we need to put AI planning in a central position in this European initiative. This is by no means the only initiatives concerning AI in Europe. There is kind of a zoo of different initiatives and different consortia and different projects concerning AI. As you can see, we are here. So in the Horizon 2020 funding scheme, there is this AI for You initiatives, and AI Plan for You, our project, is one among other projects that are trying to enrich and reinforce this European platform that is AI for EU. So let's talk about automated planning itself. That is the technology that we are trying to put inside of this platform and to sell, let's say, to use as the workhorse engine for different applications. So planning is one of those areas of AI that was considered, you know, the starting point of artificial intelligence, because planning is really the capability of an intelligent being of devising a set of actions, an idea of how to act in order to reach a desired goal. So if I want to take to go to Milan, I need to do a plan in my head. So I need to think about how to drive, that I need to go to my garage, take the car, drive in a certain direction, possibly refuel the car, and so on and so forth. So generally stated, the problem can be stated as follows. So given a model of a system, so you need to be able to anticipate what happens if you take a certain decision in your system. And system here is kind of a general word that can mean, I don't know, a robot, for example, or even a factory. So a system is essentially the set of things or the set of entities that you are trying to control. And you need a description of that in order to anticipate what are the consequences of some choices on this system. So given this kind of modeling, this kind of knowledge about what you want to control, the planning problem is try to find a way to control this system. So find a course of action in order to reach a certain goal. So I want to go to Milan. My system is my car. I know how my car works. I know how to drive my car. I know that my car needs refueling after a while, and so I can plan for going to Milan by operating properly the system that is myself and my car. Okay, so this is a general statement of a planning problem. Examples include robotics, for example. So you might have one robot or multiple robots that you want to control in order to achieve a certain goal. So for example, in a factory, you want to do automation. You have different, I don't know, a robotic arm and an AGVM, automated guided vehicles. And so you want to use planning in order to achieve a flexible and robust automation in your factory. Again, if you consider the case of a factory, maybe your system is what are the machines that are inside of my factory and what are the capabilities of my workforce. And the planning problem that you pose ourselves to solve is to maximize the production and minimize the costs in order to, you know, achieve the daily production. Okay, so maybe I can operate my factory in different way to maximize the number of items that I produce at the end of the day, for example. Or you might want to organize agricultural practices. Again, there are different ways in which you can operate in an agricultural field, and your objective there, it might be minimizing the environmental impact. So as you can see, there is a wide spectrum of possible applications. The important point here is that planning is about decision making. So you need to identify inside of your use case what are the important decisions that you would like to either automate or optimize. And once you have this piece of information, what you want to think about is what is the data that is available in order to inform this decision. You will see later in the 2 use cases that will be presented that these are actually the core bits, the really important point to identify. And as I mentioned, the project is about reinforcing the AI for Europe initiative and bringing planning there. So by showing the breadth of the possible applications of planning and showcasing the capabilities, so that in the future, after our project, if somebody identifies a certain decision-making problem in his own new domain, for example, he can look up in the AI for Europe platform and see all the experiences that we have done within the project and use planning in a more effective and in a simple way. That is something that currently is not really possible. I will go very quickly on the innovation goals. So here really the project is centered about making planning as relevant as possible in practice, so for practitioners and innovators. And we explicitly identified some issues that we would like to tackle. For example, the need for integrating planning, so this engine, this reasoning that you want to do with existing ICT technologies. So you want to inform your decision based on data that are probably provided by other or existing ICT systems. And so we want to facilitate this kind of integration. And we want really to try to find all the possible application sectors in which planning is relevant. That's why we encourage everybody that has some planning idea in mind, so to say, or some use case, regardless of the domain. So it can be manufacturing, agriculture, healthcare, whatever. Really, we are now scouting for every possible application domain here, because really one of our objectives is to see where are the boundaries of what we can do with planning. And then we have of course, the integration with the AI for Europe platform. And then we also have more like academic goals. So trying to facilitate the learning of planning itself. So we will produce a lot of material for understanding the technology behind planning. So how this decision making is actually made and how to make the most out of it. So what are the techniques for modeling your problem and to properly use a planning system in order to solve your problem. And this is going in the direction of trying to drive academic research towards this application that we identify within the project. So as you can see, pretty ambitious goals, but we think that with our consortium and possibly also with your help, if you decide to apply to our open call, we will definitely manage to do some real innovation here. So the general vision of the project is summarized in this infographic. Essentially, what we would like to construct physically, we are developing this blue thing in the middle that is a library. It's called Unified Planning Framework. The idea there is to create a library that is easy to use, and it allows you to interface yourself with different planning engines. So we abstract away the specificities of existing planning engines and provide a coherent, a simple to use interface for calling, let's say, a planning service. And this service can then be consumed by use cases by means of what we call technology-specific bridges. Here, a technology-specific bridge that is, as you can see here, is essentially the connection between the orange part and the blue part, the azure part, is a piece of code, a piece of software that is able to take a problem that is defined at the level of the use case. Suppose that you are in the logistics domain, you want to organize the activities in a warehouse. Your problem there is defined in terms of shelves, of forklifts, of pallets, and so on. So you have that kind of terminology, data structures, and so on. You want to take this information, transform it into a planning problem where we talk about variables, actions, durations, constraints, and so on. And this is the job of the technology-specific bridge. And then once the problem has been solved by one of our planning engines that are integrated within the Unified Planning Framework, you want to transform back the solution that again talks about variables, the behavior of variables, into the specific domain. So maybe you want to show a Gantt chart of what a certain operator needs to do in your warehouse for the day, right? So that's the job of the technology-specific bridge. And we would like to test this vision, this scenario in different use cases. And as you can see, among the different use cases that we identified within the project, there is also your use case, because we are open to receive additional use cases by means of our open call schema. So we have funding for actually creating and experimenting with use cases provided by the general public, so by external members outside of the consortium that we are now looking for. More concretely, so if you are interested here, there are the links. Also, the slides will be available after the webinar. Anyway, we are developing the library currently within the project, and there is a live demo that you can try there using the link at the bottom. And essentially, currently it allows you to model a planning problem from, a convenient Python environment. The idea here will be, if you are familiar with, for example, machine learning, it will be creating something similar to TensorFlow or to PyTorch. So to make it simple to operate with the underlying technology that for us is planning, for PyTorch is neural networks, and make it really, really easy to play with it, to experiment with it, so that it lowers the barrier and the knowledge needed in order to use this technology. And yeah, here you have all the references if you want to try it out. All the development is public, right? We were using a public GitHub page, and the library is permissively open source. So we are also welcoming applications for use cases that have IPR requirements, and so they might need some specific handling with their data. So we are permissively open source, and the license allows also the use inside of closed source environments. We will discuss about this one more later, but I simply wanted to highlight also what I hinted at the beginning. So what is really a use case for planning, since we are talking about a call for use cases in here. So since planning, I try to convince you that it is a decision-making technology, right? It is suitable for two things: either automate some decision or optimize some decision. And the key questions that you need to answer in order to identify really well what is a use case for planning is these three things. They are pretty easy, apparently, but sometimes it requires a little bit of discussion in order to get them right and to really pinpoint what are the important decisions and what is important in the use case. So first is, what are the decisions that needs automation or optimality? So what really is important for me to decide? Is it important to decide the trajectory of the robot, or is it important just to know where to go from A to B, and really the route that I take is irrelevant? Or do I want to optimize the battery, really? Or for me, it's more important to get the things as soon as possible. So what I want to optimize is the timing, right? So this is the kind of question that you need to ask. Then, since probably there are this decision and there is a status quo, so these decisions are being taken right now, either automatically or manually by some person. What is the data that is available for taking this decision? So, for example, is the orders available beforehand? So at the beginning of the day, I know all the orders for a factory, for example, throughout the entire day, or the orders arrive in batches, or the orders simply arrive when they arrive, so one after the other. So, and it's also important to understand whether there are constant characteristics or contingent events. So something constant might be, for example, the shelves in a warehouse. It's pretty rare to change the amount of shelves that you have in a warehouse, versus orders are typically something very contingent. It depends on the market. They are very hard to predict. So this is also something to be taken into account. And finally, how often and when is the decision to be taken? So is it something that I need to decide every hour I need to take a decision? Or is it something like I need to plan for the entire shift, so like an 8-hour shift in a factory, for example, and then I have 8 hours to decide for the next one? This is also very important to decide whether you really want to push for optimality or whether you want to push for reactiveness, so to get a solution very quickly instead of a very optimal one. And then finally, let me talk about this, what we mean by integration in the AI4U platform. So I mentioned at the beginning that this is one of the overarching objectives of the project. And here we mean two things. So on one side, we want to use the platform as a sort of a showcase for AI planning. And so the use cases the experimentation that we do within the project will be presented in the platform, for example, by means of interactive programs or by videos and let's say educational materials. The idea there being you can play with planning. It's sort of a test before you buy schema, right? So you can see what planning can do and what it has done for other companies, possibly in your sector or in similar sectors. And so you can, let's say, try to buy in the idea of planning even before investing real money on it, right? So it's more like a, showcase. That it's probably the best word for it. The second thing is that this technology, this UPF, so the Unified Planning Framework, and the technology-specific bridges, they have a value of their own. So they allow you to do things in a way that is simpler, and possibly the technology-specific bridges can be reused across different domains if they target the same technology. And so we will provide them as downloadable resources within AI for You, so that future users of the platform can actually see these resources listed in the catalog of the available AI assets, and they can reuse it, possibly doing business on top of them, in order to address their planning problem. And of course, this is important also when you have to solve a planning problem of complex size, because the computational resources can then be provided by the user. For example, you can buy some cloud resources in order to solve your logistics planning problem, for example. That is something that the AI for You platform cannot provide. And in addition to this one, we will provide in the platform training material, and we call it planning cookbook. So a sort of recipes that are derived from our experiences that will try to guide the user in what are the best practices in order to address a certain kind of planning problem. So this is what we're going to do in the project itself. And as I mentioned, and this is actually the reason for this webinar, we have a cascade funding schema within this project. So we have some funding for financing, let's call them some project or initiatives from third parties. And they are of two kinds. One, that is the one that is currently open, is a call for use cases. So here really we are trying to look for new use cases for planning technology to be possibly included within the project. And here the idea is really to understand and scout problems, challenges for the planning technology. Therefore, I encourage you, if you think that you might have in mind an application for planning, to apply, because here the real advantage is that you will be invited to participate in a workshop with our experts in planning. And we will try to really analyze in full detail whether and if planning can be relevant in your domain. So really at a zero cost, and actually getting some money for participating in the workshop, you can rule out or let's say identify really what is the possible impact that planning might have in your use case, in your application domain. And then we have a second kind of open call that are called call for innovators, in which we really finance some pilot problems, and some of them will be grounded on the use cases found or elicited using the other open call. And here we are looking for people that are willing to actually experiment really with planning problems, either by providing additional engines or by providing a demonstration of using our unified planning framework by providing a use case and a TSB, so a technology-specific bridge, or by developing a TSB for one of the use cases that has been identified using the other open calls. And currently, actually, we have the open call that is open is this call for use cases. But just to give you an overview of what is the program of the entire project. I hope I was in time, Marina. And that's it for the project. But if you have any questions, just drop them in the chat and I can try to answer. Thank you.
Thank you, Andrea. It was very clarifying, I believe. So as Andrea said, if you have any questions or any doubts or whatever, just put it on the chat. We will be sure to answer all of your questions and clarify everything for you. So I think we can move on, and I will now give the word to Guglielmo from Magazino.
Cool. Thank you so much. I hope you can hear me.
We can.
Let me start by sharing. Can you see my screen?
Yes.
Okay, cool. Thank you so much. So first of all, I would like to thank you guys for having invited me today here. So I've been asked to talk a bit about what we do at Magazino and how we applied or we participate into the AI Plan for EU project. So first of all, I would like to spend a couple of words discussing our product. So Magazino is a robotics company, and what we do is mainly produce 2 robots. So Toru is our older robot, so we've been developing it for the past 7 years now, and it's a robot, you'll see it in a second, that is supposed to basically autonomously work in warehouses together with humans. So from a user's perspective, this robot is treated exactly as a human. So these robots are given a list of tasks to be executed, and they go around in warehouses and pick boxes, shoe boxes, and they deliver it to actually where they need to be delivered. Soto instead is the newer robot that we are developing. It's been about 2 years that we are developing this robot. This robot is more thought to work in production lines where we have to move KLTs. There are these plastic standard boxes used in production lines that they store goods. And these KLTs can go up to 20 kilograms. And this robot is way bigger than Toru. Think of it as like 3 times as Toru. And as Toru, it has to go around, locate the boxes, KLTs, and deliver them. These robots, they all work with a framework that we have developed. It's called Acros AI. It's a framework that runs on both robots, but we are also selling it, and we are supporting other companies to actually develop new robots. So this is a framework, is a software stack that is built on ROS. And we are using this, so the software that is running on Toru and Soto, parts of it, we are giving it out to other companies to basically make their robots also autonomous. What I do at Magazino, I'm one of the four software team leads. You can think of my team as the robot integration team. So there is a part of the team that is taking care of the behaviors of the robot. We're going to see in the presentation shortly what I mean by that. But basically, in terms of planning, this team is in charge of coming up with the plans to be executed by the high-level plans to be executed by the robot. The other part is doing the QA part. So putting together pieces of hardware and software and making sure that what comes out can be called an autonomous robot. But to be a bit more concrete, let me show you a quick video about Toru. So here, this video can also be found online. But to give you an idea what we're talking about here, it's a classic warehouse that stores shoeboxes. So if you go online and you want to buy a new pair of shoes, basically you order something, and this usually goes to a warehouse management system that sends a bunch of picks that humans need to do. And so in these environments, you have often humans that they are doing their job, and our robots are working, need to work alongside humans. And of course, if you have humans around, there is quite some noise that is introduced. So the challenge with these robots is to basically be able to cope with the noise that is produced and work seamless alongside the humans. So these robots, they are quite complex, I would say. So you can think of it as a diff drive-based robots that can autonomously localize in the environment, navigate in it, and then it uses we call it the tower to scan for boxes around the environment and store it inside the backpack. Here, as you can see, it's one of the interfaces that we have developed to work alongside the humans. So when the robot is done picking the boxes, it just stores it in a movable shelf that can be taken by a human and then delivered somewhere else. Of course, here you also have the problem of multi-robot coordination. We have up to 30 robots in a floor that are currently working nowadays. And of course, you have to coordinate them all. So I hope that this video gave you a bit of an idea of what Magazino is working on. And now, how is Magazino working in the, so how does Magazino fit in the picture that Andrea just talked about? And so Magazino is mainly taking, so looking at some problems in the logistics automation use case in collaboration with Autopro. And we are providing one of the use cases, or actually two use cases that I'm going to talk in a second about, as test benches, as use cases for applying this planning technology. So what does it mean? If you think about this kind of robots in this particular case, so those from a planning perspective, solving a planning problem from in this particular domain means to have programs or planners that are able to deal with action failures and recoveries. They have to be able to understand derivative actions and parallel actions, have to handle unpredictable events, think about the humans in the environment, and they have to kind of be able to manage partially known state and anytime restart capabilities. So maybe taking a step back, how can we kind of model the problem that we're talking about? So usually when we discuss about the logistic automation use case, we think about autonomous robots for pick and place operations. So abstracting a bit away. And these robots are tasked with the high level commands. For example, pick a box from X, box X from shelf Y and bring it to shelf Z. And this task, they need to be carried out autonomously. So in Magazino, what we are doing, we are actually crafting via hand. So we have handmade plans that are expressed as behavior trees. Well, it's a particular formalism of behavior trees developed by Magazino. There you have the reference for later about if you're interested in the patent. But roughly it's behavior trees, and these behavior trees are responsible for carrying out assigned tasks and recovering for issues that might arise during operation. For example, I don't know, the robot is told to find a box in a certain shelf, and the box is not there when the robot arrives there. So the behavior tree is in charge of taking care of this kind of issues. Just to give you an idea of behavior trees, as I was saying, so behavior trees are a formalism where plans are expressed as trees, where you have a composite, so nodes that have multiple children. You have decorators, which are nodes that have only one child, and you have leaf nodes that can either represent a condition or an action. And these trees are traversed at a constant frequency, left to right, top to bottom. To just give you a really quick, I don't want to give a lecture about behavior trees, but to give an idea about how behavior trees work, I usually like to use Pac-Man as an example. So think of wanting to describe the behavior of Pac-Man in this particular example, top right. So if we take this situation, what you would have, the evaluator of the behavior tree. So this behavior tree could represent the behavior of Pac-Man in this particular world. And in this particular case, you would basically evaluate, and at every tick, you would go through, traverse the tree and answer or execute answer the question, the conditions that are posed, and execute some actions. In this particular case, you would ask yourself, is the ghost close? No. In this particular, no. So because of this particular decorator and this particular decorator, you would jump here and basically go into eating pill. At any point in time, if the ghost would come close, you would, because you're evaluating this tree at a constant frequency, this evaluation would change, and you would go in one of the specific actions to be executed. Now, I wanted to talk about this to give you a bit of a background of why we thought that planning could be a good use case for us. In fact, we are describing behavior trees as so we use behavior trees to describe the plans of our robots, and these plans are pretty big. In order to develop these plans, we we do need expert knowledge. So we need users that really know in depth the robots. But in order to do so, while doing so, this activity is really labor intensive, and this activity exhibits a high probability of often finding logical errors in programming or errors due to unforeseen combination of environment factors, and so on and so on. So this is quite labor intensive. So therefore, we thought, okay, maybe with planning we could actually avoid at least part of this hand making process. And discussing a bit with our university partner, with Orbro, and actually also with Andrea, we had quite some discussions, and we came up with two particular use cases. The first one, it's about having a planner that aids our engineers, our developers, to help them to aid through this behavior design process. The second part is more like this idea of having a planner that actually controls the executions of a robot. And so we thought about a use case for actually having an online planner that actually conditions the behavior tree. But let's see more the details about it. So starting from a offline behavior design guide. So we thought about taking at Magazino, we have a front end that we use. So it's a web page that we use to develop these behavior trees by hand. And these behavior trees, with this front end, you can produce behavior trees that can be converted into planning problems. And then you can use a planner that can check the soundness of such subtrees, and it can help the user to basically check some of the scenarios. So answer questions like, are all such scenarios correct in every case, or are all the outcomes been taken into account? And by having a planner, not only we can check all these scenarios, but also planners have the nice ability of introspecting them. So we can actually understand when, in which scenario, we actually our plan, the plan that we have crafted, is not actually satisfying the requirements. The second use case instead is so assuming that we are able to write some of these trees. Now we could think of these trees as primitives or actions in planning that we can use a planner to compose these primitives at runtime via an automated planner, in fact. And here you have a really abstract, let's say, diagram for how we are thinking about exploiting it. But basically what you could do is give the planner a robot state that, of course, is built by using the sensor on board of the robot, the environment state, and then the goal to be achieved. And by exploiting planning technology, what you can do is condition the behavior tree in order to achieve the goal given or the task given to the robot. By using this, we believe that with the first use case, we believe we can reduce the effort for building these handmade subtrees, and of course reduce the amount of bugs delivered to the customer, which for us it's a huge cost that we have. And with the online planner, it's a matter of or the goal that we plan to achieve is to reduce the maintenance effort of the trees and have a way faster development of new features in specific circumstances, since we can abstract away the problem that we're trying to solve through a planning technology. I hope I was in time. If there are any questions, thank you so much for the attention. Yeah, I'm available for anything. Thank you.
Thank you so much for explaining these awesome things that you are doing at Magazino. I'm really impressed. It's really cool, and it's really an asset to the project, and the project is an asset to you too. So, well, this was great. Thank you.
Thank you so much. Thank you.
Again, if there are any questions, please put them on the chat. We will answer everything. And so I'm giving the word now to Lorenzo and Marco from Saipem. So go ahead and present your use case.
Okay, thank you and good afternoon, everybody. I hope you can hear me.
You can.
Okay, I'm going to share my screen. Okay. So again, good afternoon to everybody. I'm Lorenzo Granelli, working from Saipem since quite a long time. I'm a technician acting sometime as a project manager. In this case, I'm doing project manager, and Marco, my colleague, is doing the more exciting parts of all the technical stuff. And we work for Saipem. Saipem is a very, very large, worldwide spread, public shared company. We are present in 60, maybe more countries. We have fabrication yards here and there. And we do engineering for the energy market. So traditionally, you can translate this with oil and gas. Now we are facing the energy transition. So some of our biggest contracts and works are involving or dealing with offshore wind farms and other forms of alternative and more green energies. Our company is now split in 4 main divisions. One is dedicated to the sustainable infrastructures. One is for the asset-based services, so whatever requires a vessel for offshore operations, or drilling machines for onshore or offshore, or installation tools. Another division is dedicated to the energy carriers. And then last but not least, we have the robotics, digital, and industrialized solution, under which Marco and myself works within the Sonsub branch. Sonsub is a kind of small company in the company. We are a little bit more than 100 employees working in Sonsub. And we have this mission, which is not official, but it is our mission since a very long time. We are the ones that build and generate value for Saipem, doing all the strange things that others doesn't do or are not available on the market. Particularly, we work for subsea robotics. So whatever happens offshore, whatever happens under the sea, and needs some robotics, some particular machine or feature, we take care of developing the machine, the feature, the software, the hardware, whatever our company requires. We have different sub-branches, a part of all the staff roles, such as procurement or asset and operations management. We have the innovation, automation, and digital sub-branch. We have the products and system development. And then we have 3 sub-branches which are more focused on market fields. So life of fields, meaning all the services required by an energy field during its life, from building up the field to dismantling, decommissioning, and recycling the field. We have the subsea factory branch. Subsea factory is that part of activity required to move from the surface to the sea bottom some processes, like some refining process for gas or oil, or some other newer process for energy distribution coming from wind farms or things like that. And we have something which is quite new to us, which is the military market. Our story starts in the late 80s. Sonsub was an independent company which has been merged into Saipem or ENI and then Saipem to form Sonsub SPA. So again, public share company. Then we have been merged again within the Saipem, which is the holding company. We started producing trenching machines and ROVs, so machines that are required to remove or build up trenches for pipes or cables to protect pipes and cables, putting them under the seabed, or ROVs, which has remotely operated vehicles, so big robots operated by means of a cable from a vessel. Then during the timeline, we developed more demanding, more complex operations and machines. Nowadays, we are dealing with drones. We are building up a family of drones. So single platform providing different features for subsea operations. We are nowadays speaking about the iDrone R, meaning resident vehicle, which is a small world-class ROV capable of autonomous operation, like moving from one station to another independently or to carry out a survey in an autonomous way. We are now in the testing stage, final testing stage of the Flatfish, which is less ROV and more AUV, so it's more torpedo-shaped vehicle capable of wider range, much more flexible in terms of inspections and data collection, but without arms, so without the capability of interacting with the field by itself. And now we are engineering and starting the production of the iDrone W, which will be our first fully electrical subsea vehicle. These different machines sharing the same platform, both partially hardware and completely software, forced us to work with planning techniques, AI techniques, and smart programming techniques. So we were collaborating with Andrea and FBK since years nowadays, and we take the opportunity and the occasion to join the project, bringing to the project itself our use case, where we will mainly be involved in the definition of a use case, which will give to the universal planner a set of requirements that are maybe peculiar to our use case, hopefully shared by many other use cases. We are now starting to develop our technology-specific bridge, so the piece of software that will be required to integrate our software with the planner itself. And we will be deeply involved in the evaluation work package, so to test the results of both our technology-specific bridge and the universal planning system. Now I'm leaving the floor to Marco, who will describe in much more detail our use case, and I'll be back to you to talk together about the opportunities that we see in this project. Marco, it'll be in your hands, so just let me know when I have to switch the slide.
Sure, thank you. Hello, everybody. So thank you, Lorenzo, for the introduction and for the first part of the presentation. So just to give you a quick overview on the, let's say, state of the art, which introduces our use case. So you need to understand that basically behind, let's say, deep down into the water, there is the so-called fields, oil fields and gas fields. So down there is like a small city. So the so-called state of the art of the life of field requires us to, let's say, go there to maintain and to control and operate something on those structures down there. So these small cities are composed by small structures, small and high and big structures that are connected through pipelines, okay? Mainly, basically, I would say kilometers of pipelines. So all these cities are very spread, let's say, in space and connected by those pipelines. So how do we control this type of structures? Well, we need a vessel there. So let's say fully equipped vessels with technical people on board of it and particular instrumentation, such as a launch and recovery system, such as particular vehicles. And nowadays, these type of operations are performed with remotely operated vehicles like the one depicted in the picture, or the ones you can see on Lorenzo's background right now. So basically, these type of operations are pretty much expensive, because a vessel can easily cost tens of thousands of euros per day, up to even hundreds of thousands of euro per day. So our idea to, let's say, enhance and improve this state of the art was to introduce a new type of vehicles. Okay, so please, Lorenzo, if you can go to the next slide. So Lorenzo already introduced you this type of vehicles. Basically, they are the Hydron R, the Flatfish, the Hydron W. All these vehicles are under the so-called Hydron platform. They are mainly, let's say, electrical, even if some of them, not really all of them electrical, let's say. They have they are actually autonomous underwater vehicles, okay? While some of them can be even remotely operated vehicles, they still have, let's say, the capability, the intelligence, and even the technology to perform autonomous operations. In my opinion, or let's say that the biggest challenge and the biggest innovation of these new vehicles is that this type of vehicles can be even resident. What does this mean? It means that they have a garage down there where they go and they recharge batteries and they, let's say, sleep until an operator asks them to perform something. The requirement was that they need to be resident up to 2 years down in the water with a depth rating of 2,000 meters deep down. So you can imagine our mechanical team needed to face many challenges about this, about the pressure, about all this type of all the problems you can have to make those vehicles be resident down there for such a long time. Last but not the least, these type of vehicles can be operated, let's say, from home, from an office. And this is another big innovation, because you can imagine this way, those vehicles being resident, being teleoperated even from home, from the office. It means that we do not need a vessel anymore. You can imagine that these type of vessels, the one you saw before, are not, let's say, normal vessels. Normally, if you're using a vessel, you're probably stealing it from other things that the vessel could do. So it's going to be a big problem. Okay, Lorenzo, if you can go to the next one. Okay, so normally a typical mission these type of vehicles need to perform can be the one depicted in this slide. So right now we are seeing a sort of semantic map, bathymetric semantic map of the playground we have in Trieste, where we test our vehicles. So the vehicle has a garage from where it needs to, let's say, from where the mission starts. The operator can ask the vehicle to perform this type of mission, like go exit the garage, go over the pipeline. When you cross the pipeline to right, follow the pipeline. At the end of the pipeline, you know that there is a structure. You're going to see it. And there are 2 valves. Please operate valve 2. Okay, then go back home. This type of missions can be this one looks pretty much simple, actually can be really complex. Okay, but as you can understand, there are a variety of things that a human written mission potentially could not cover. So Lorenzo, if you can go on, please. So basically, the big question we are hearing a lot today is why planning? As even the last use case showed us, if you have an autonomous robot, it's difficult not to use planning, okay? Because let's say that the other way not to use planning is to use humans. Okay, in our case, it means that a human should write a mission that the vehicle can perform. But we have problems about this. Why? Well, we need to deal with the resources, and most of the times, resources are not just one-dimensional. In our case, we have batteries, we have disk space, we have efforts, we have lots and lots of other things that needs to be, optimized in some way, even the time or the space traveled. So a planner can give us a better resource management than the one the human could do. Okay, it can even give us a solution in a shorter time. So the missions have to, to be given to the vehicle in a faster way. A planner can even give us the possibility to cope with abnormal conditions and failure of mission execution. For example, imagine that the vehicle is traveling and something bad happens, like I lose one battery or something like this. Well, in a human-written mission, there is no much other way than, say, go home or something like this. A planner can intervene in real time and say to the vehicle, look, you lost one battery, but probably the energy is enough, so let's continue to do the mission or something like this. So this way, the planner could give us a way to not to lose time and to cope with this type of uncertainties and events that could occur. Again, even the mission definition can be independent from the field. Indeed, given the semantic sim map of a field, I can write missions that are very general, like go on structure called like this and turn this valve. So very general let's say very general mission definition thanks to the planner. So please, Lorenzo, go on. Other things that can help us with planning are exploiting opportunities. So, for example, my vehicle is traveling on top of a pipeline going to a certain structure, but at a certain point, I detect a leakage or something like that on the pipeline. Well, a human-written mission cannot cope with this type of things. The mission will just go over, and the vehicle would go to the structure. But with a planner, I can take the advantage of this and say, look, I have enough resources, the time is fine. Let's have a look, let's have a closer look at this leakage to just gather more data for the operators back home to see if this leakage is important or not. So the mission can be enriched with a survey, with a better survey of the area, interested area. Again, if I still want an expert behind my machine, I can still cope with human-written missions, but the planner can at least tell me if my mission is well-written, or if I will encounter some problems, or if it is likely that I will encounter some problems. And this is a very nice feature, in particular for this stage of our projects. Or again, if you have some manipulators on board, like the Hydronar depicted right now in the picture here, you can even ask the planner to give you a plan to autonomous manipulate a valve, because which is something interesting for us that is not yet performed by our vehicles. Okay, so more or less, this is a very high level overview of what planning can give us in our use case. So I give the floor back to Lorenzo, who is going to talk to you about why a plan for you, for example, because planning is important, but why this particular European project, for example. Thank you, Lorenzo. The word is back.
Thank you, Marco. And this first slide has been, let's say, anticipated by Marco. So basically, we have some performance that we think autonomous planning and AI can improve in our machines. First of all, the success of planning. So we expect that percentage of missions, successful missions, will increase significantly, especially when missions becomes more complex. So with more targets, more complex and heterogeneous targets. And moreover, the planner should be, we expect that will be able to produce missions that consume less resources. So more optimized missions with respect to what a human can do. We expect to have an increased efficiency of planning. First of all, in terms of user time. So the time that an AI planner will use to set up a plan, especially if it is very complicated. So with 2, 3, 5, 10 targets within the same mission that may be 5, 6, 10 hours long, a planner, automated planner, should be much faster than an operator. And this saves time that may be critical for our organization or for our clients, because if we need to collect data because there is a problem on the field, we simply cannot spend hours to set up or build up the plan. And again, a planner should use much less resources according to resource consumption priority required by the operator, and this will allow to program wider and longer missions with more target in less missions. We expect benefits in the exploiting of opportunities. So the planner that must run in real time should be able to readjust the mission, adding or removing targets according to the level of available resources. So to exploit and have the maximum benefit that it is possible to have with the model of the system, with the actual model of the system, including availability of resources and unpredictable resources consumption, such as if we have strong marine current, resources may be consumed quicker than expected. So we need to readjust the mission. The planner needs to readjust the mission to avoid losing the vehicle because of lack of battery, as an example. Side advantage could be the model of vehicle that can be adjusted time after time, collecting information by the planner itself that can use those information and its own experience to build up better missions in the future. Last but not least, the vehicle safety. These kind of vehicles are not exactly cheap. They can cost from 1 million to 5 or 6. So if we lose one vehicle due to an unpredictable, unexpected, abnormal condition, or caused by a wrong planning by a human, this can be a strong impact on our business. We are losing valuable assets. Then this is a list of business opportunities that we expect in return of applying artificial intelligence and planning techniques to our platform. So we expect to increase business opportunities just because autonomous subsea machines are not existing nowadays. So we are the first in the world to propose to our clients these kind of solutions. We can save vessel and asset costs. As Marco explained, one of our vessels can easily cost over 100 kilo-euros per day, which is really impacting in the business of ourselves and the business of our clients. If we can save a vessel, we can do much better business. And again, we can avoid to lose our vehicles due to unexpected conditions. We expect to reduce operations risks just because operating a field has implicit risks, and having those autonomous vehicles capable to survey the field more frequently than you can do with a vessel and an ROV allows, say, predictive or early maintenance, allows to reduce reaction time in case of faults or problems. And last but not least, we expect to have a reduction of operators' training time, because without planning or autonomous planning, an operator should give to the orchestrator, so to the system, the whole mission, should handwrite the mission. So basically, we need to use engineers as operators, or we need to try to train our operators at a level which is very close to the knowledge of the system that an engineer must have. So we may end up to have overtrained operators or engineers use it for tasks that are not good for an engineer. So an engineer is too much expensive to work as an operator. And finally, benefits that we expect participating to A-Plan4U. Basically, we entered a consortium, so we expect a very, very large investment leverage. This is a co-founded project. We are an industrial partner, so we are not 100% founded by European community, but we are largely found. So we are participating to a 5 million euros budget project with really minimal financial investment. And all the benefits that coming from the availability of heterogeneous experiences and competences that are shared across partners. We are creating a network, which is the second main point, with other industrial partners and research and scientific partners who represents the state of the art about planning and have all the possible problems in planning. So we can have different approach, we can share ideas, we can reach the critical mass to solve apparently different but really common problems. So thank you for your attention. In case of any question, just write down. We will do our best to answer your question.
Thank you so much, Lorenzo. Thank you, Marco. A very different area from the one we saw at Magazino. A very different application of a use case. Thank you so much for talking about Saipem to our listeners and to us also to the. Okay, so I will just now give the word to Luisa. Luisa will explain now the juicy part. Now that you have seen how planning can apply and how problems can be solved with AI planning, now Luisa will explain all about the open call and how you can apply and walk you through all the guides and procedures to apply to this opportunity. Go ahead, Luisa.
So thank you, Marina. So let me share my screen. So can you see my screen?
Yes, we can.
Can you hear me well?
Yes,
okay.
Perfectly.
So thank you for having me. Good afternoon, everyone. So I'm Luisa from F6S, and I'm going to, as Marina mentioned, I'm going to talk about how to apply to the open call. So first of all, it's important to introduce F6S. I work from F6S, and F6S is a leading platform for application management for commercial, corporate, government, university, and other accelerator programs. In practice, it's a global founders community that connects different companies and different startups and investors, and also to offer different opportunity for them. So it means that it's all about funding for these startups and investors and innovators and accelerators. So in terms of numbers, just a short vision here, the company processes every year more than 700,000 applications and delivers about 2 billion euros for different companies, startups, SMEs, and etc. So inside that success, we have a governmental department that deals with different projects, including European Commission projects. For these reasons, we are partners in AI Plan for You, and we are responsible for managing the open calls. So just to have a short vision here, we are responsible for bringing external use cases to the project. So as mentioned by the other partners previously, we have here internally, we are developing internally different use cases, and your use cases will be part of this ecosystem through the open calls. And our mission here is to bridge the external companies, startups, and organizations that will apply and use cases and bring them to the ecosystem of AI Plan for You. So let's go to the point here, and I'm gonna talk to you on how to apply to the open calls. So as mentioned by Andrea in the beginning, we issue 2 different types of open calls. The first one is the open call for use cases, and the other one is the open call for innovators. We are here for the open call for use cases that aims to connect different stakeholders and from non-tech sectors, and in order to help the other partners to develop the TSBs, and we are accepting different use cases from different contexts in order to bring some diversity and to test the use case and all the technology in the AI for You platform. So we are in the second open call now. We issued a first one in March of 2021, and now we are the second open call is open until the 10th of February. And we will have a third one in the future, and this date is not defined yet. So, I decided to include here the open call for innovators, as mentioned before, because the open call winners from of this open call use case will have the chance to work with us in the second open call in one of the tracks, in order to help the TSB developers. So we still don't have a date defined here, but the most important message that I want to leave here is that if you intend to participate in this first open call for use case, you have the chance to also participate in the open call for innovators and to get more funds, because the open call for innovators is a more technical, and a lot of developments will be carried out in this open call. So, and of course, you can also be part of this open call. So, in terms of budgets, we have here the open call for use case will fund the winner use case with 1,500 euros. So we intend to select 5 projects for this, and I also included this table below for the call for innovators, just for you to have an idea of the chance that you have to be funded with more 30,000 euros if your use case is interesting for the project. So it's just to have an idea, and the overall amount to fund the third part is about 2 million euros. So it's the total fund of the project that are dedicated to the third parties. So let's go here for the process itself, because we have here a very organized process to evaluate, and of course to bring this use case to our ecosystem. So first it starts with an application, and then your application, your proposal will be evaluated by our partners, our technical partners. And if it's selected, you will sign a sub-grant agreement. And of course, for some months, you become a partner of this project, and you will participate in a workshop, and then you'll be funded with this 1,500 euros. But I'm going into details with this. I'm just giving here an overall overview of the journey, but I'm going into details just to explain each stage. So let's hear. It's important to highlight that before submitting, you should take into attention to some details. First of all, we make available all the information necessary for you to check if you are eligible or not, because we have some rules here to accept your proposal. So in practical terms, the first thing you should do is to access our website. So the AI Plan for You website is available, and all the information about the open call is available there. So when you access the website, you just click on the top of the page, Apply Now, and there you will see all the summarized information about the open call. And then you should click on this both documents. Here you find a text explaining the project and the context and just a general overview of the open call. And this one, the guide for applicants, is the most important one, is where you're going to find all the rules to apply to the open call and to be eligible, and of course some guidance in order to prepare a very quality proposal. So you should read the instructions. For example, I just give an example. Check if you are eligible. The eligibility criteria is listed there in detail. So, and you of course check if the funding is enough for you, if it's okay, and if your company fit to the open call scope, and if you are available, for example, to dedicate to the project for a specific period. In this case, the program duration will be 1 month. So before deciding to fill the form, just check this important information, and all this information is available in the guide for applicants. So then, after reading the documents and check if you are eligible, you are ready to apply. And then in the bottom of the page, you find a link, and this link will guide you to the form. So we have prepared a very simple form to fill. You don't need to answer a lot of things, and you just need, there are some you need to fill in with basic information. So the only thing that I would like to highlight here is that you need to use a template in order to specify your use case. So here you can see the picture of the form. So I just would like to highlight this, because this document, it's a very brief document, it's not something very difficult to fill in, but the evaluators will understand your use case and analyze if your use case is okay to advance through these documents, through the description. So it's very important to download this document, fill out with the information, and then upload again in the platform, in the form. So, and we put there the link. So you just click on the link and you will find the document. It's a Word document. So I put here the picture of this document because here, as you can see, we even limited the number of pages in order not to write that much. And we put here some questions in order for you to be assertive in this in the description of your use case, just to ease and help you to prepare a quality proposal, and of course going to the point, because it will be easier to evaluators to analyze and your proposal and understand as better as possible. So and then if your use case, if your proposal is eligible and if your proposal is okay, your application will advance to the evaluation stage. So the consortium partners that are also experts in AI planning will analyze your proposal, will evaluate your proposal according to some criteria that was already established before. For example, they will check the technology innovation component, the impact, and the integration plan. So, and then you can be invited for some online interviews, but it's not mandatory. Only if the evaluators decide that they need to understand better your proposal, they will invite you for an interview. And then we'll have a consortium meeting to decide who will be the 5 use cases that will advance and will participate in the workshop. So, and here is just the next phase. Of course, if you are eligible and accepted to participate in the project, you receive an email saying that you were accepted, and then we move to the legal part. That is the contracting phase, that you will sign a sub-grant agreement with the coordinators, that's the FBK, and there they will check some documents and ask you to sign some documents and some forms, and to fill out some forms. And then finally we are going to the implementation of this open call. So in this open call for use case, it consists in the participation of in a workshop. And in this workshop, you have the opportunity to know the other partners, and they will bring you some feedback about your use cases, and they will guide you through the process. And you have the opportunity to detail and to explain everything about your use cases. So the financial support will be to third parts, will be in the form of a grant lump sum. So, and of course, after this workshop, it is a one-day workshop, the partners will decide if your use cases will have the chance to participate in the open call for innovators and or not, because this stage is very important in order to detail it, to understand. Of course, you will detail your use case through that template, but this workshop is a very, very different stage. It's a more advanced stage where you can talk to them technically and and they can identify the pain points and what's good, what's not so good. And it will be a very important stage in order to decide if you can advance to the open call for innovators or not. So just wrap up here, because I brought here so many information. So we will select in this open call 5 use cases, and it will be a very important stage for us to bring more use cases to the project. Of course, we are developing internally different use cases, but your use case is another component, and it is very important. It will be very important for the project. So your use case also can help us to select an innovator in the other open call, the open call for innovators. And of course, if your use case is okay, and you can be selected to be funded with more 30,000 euros. So it will be a very good opportunity for the use case winners, and of course for the whole consortium. And here just a small highlight, who can apply. Of course, the target are single organizations, the different companies like SMEs, mid-caps, research institutes, universities, and also individuals. So if you are an individual, if you are a professional or a student that aims to apply with your use case, you can also do. So the deadline is the 10th February, so we still have some more days in order to, you still have some more days to apply. So I recommend that you advance, so, and don't miss out this opportunity. For sure, we are, if you want to have more instruction to apply, you can access our website. All the information is there, as I mentioned before. And if you have any specific question or you need some support with the application, you can contact us directly. Do not hesitate to do this through this email address that I'm showing here. So just reach out to us. So thank you for your attention. If you have any question, I will be glad to answer. So thank you very much.
Thank you, Luisa, for this clear explanation of the open call process and of who can apply and how we can apply.
Okay, thank you, Marina. I'm just trying.
You were trying to unshare
Yes.
your screen.
I'm
Okay.
struggling here with Zoom. Sorry for this.
It's okay. So now I would just want to give some time for some questions, if any. You can see my screen, right? I'm sharing again. Yes. Okay. So as Luisa mentioned, you have all the information on our website. You can contact us through this email. The webinar will be available at the YouTube channel, AI Plan for You YouTube channel after, maybe tomorrow. You can rewatch it and see all this information again. And I brought here some questions that usually people make us, that we have been hearing from during this process of open calls. So let's go over them really quickly to clarify some things. So about the open call, who can apply? Can a consortium apply or a master student? Luisa, you already answered to this, but you want to?
Yes, for sure. So yes, a consortium is not allowed this time, but we will have some other open calls that we will allow that a consortium to apply. And a master student, of course, he can apply as an individual. But if he wants to apply as the university, so it's a single organization. But we put this option in the form so he can choose. If it's a university, the university will be funded. If he applies as an individual, he will be funded as an individual.
Okay, next question. Oh, sorry. Which areas of domains are the project looking for? Basically everything. We are not restricting to any areas. We just want problems that can be solved, planning problems that can be solved through this AI planning technology, and that will enrich our projects and that we can help you with. Basically, I believe is this. No areas are forbidden. Everything is permitted as long as it's a planning problem. Which countries are eligible? Luisa, want to take over this?
Yes, European countries, members of the European Union and the associated countries. So in the guide for applicants, you find the link with the list that will guide you directly to the European Commission website where the countries are listed there.
Okay, when will the final results be announced, Luisa?
So 1 month after the closing of the open call, maybe 10th of March, until 10th of March, we will announce the final results.
Okay. What type of costs can be funded, can be covered by the funding?
Oh, actually, as we are in the pandemic phase, it would be, firstly, it would be used to fund the travel and to the workshop if the applicants should travel and to pay the expenses. But as we are in the pandemic phase, so the only thing that they should do is to attend to the workshop and participate, and they will be funded.
And the selected projects are giving the funding in advance?
Yes, it's a lump sum. So right after the participation in the workshop, they will be funded.
Okay. I think Andrea already answered this one. How will the use cases be integrated in the AI4U platform? But if you have just a few minutes to explain.
So we'd like to feature your use case in the AI4U platform, of course, giving credit to you, to the company that is presenting the use case, and then you will be given the opportunity to actually develop your use case if you decide to participate also in the call for innovators. And there we will develop your use case, and we will try to let's say develop also a demonstrator that will be stay there resident in the AI4U platform for future reference and also for your advertisement.
Okay, and how does the project handles intellectual property rights?
That's a very good question. So we are very open, and we are very aware that some data and some parts of the use cases might be covered to subject to intellectual properties. So on the licensing side, we are very open. So it's okay to propose or to let's say present use cases that do have the requirement of a closed source license. Sorry, it was a mouthful. What we ask is to have, for example, some abstract data or some anonymized data that we can use for our experimentation to show that actually planning can be used in your use case. And some general description or publicly shareable description that we can use on our website and on AI4U.
Okay, so if there is no more questions, I don't think there are. I would like to thank everyone that was here from Saipem, from Magazino, Andrea, Luisa, Lorenzo, Guglielmo, Marco, everyone. And if you have any more questions, just go to our website, aiplan4u/project.eu. Contact us through the email address, and you can watch the replay of this webinar on our YouTube channel. It will be available after tomorrow, I believe. Thank you all. Thank you so much for your participation.
Thank you, everyone.
Thank you.
Bye.
Bye-bye.
Bye-bye.